Alright, for those of you that are having a little bit of trouble with ice tables, I'm going to go over the one we did in class and go a little slower through it so you can watch it again. And then I will do a new example as well. So ice tables are ice tables because we're talking about initial concentrations, the change in concentrations, and the equilibrium concentrations for a chemical reaction. Okay, so at equilibrium, rates are going back and forth at the same amount, all right, at the same rate. But until they get to equilibrium, they are going to start making reactants and products in order to equalize themselves, in order to become equal. So we use ice tables in order to predict what the concentrations are going to be like at equilibrium when they have finally reached that equilibrium position and both rates are the same. So in this equation, or in this problem, we have iodine and bromine, and it goes to iodine bromide. All right, and it's saying we started off with 5 moles of iodine and 5 moles of bromine, and we know that when the container achieves equilibrium, the flask is going to have 0.84 moles of iodine bromide. All right, so we set up our ice table. Oh, sorry, my bad. First thing we need to do is we need to write our KEQ expression. So KEQ is products over reactants. Iodine has a 2 in front of it, or iodine bromide has a 2 in front of it, so we need that squared. Alright, so then after we write our equilibrium expression, now we set up our ice table. Rewrite the equation, then ICE, initial change equilibrium. So we know our initial is 0.5 moles. However, we're dealing with concentrations, so this has to be a molarity. It's got to be moles per liters. So I'm going to take 0.5 moles, I'm going to divide it by 1 liter, and I'm going to get 0.5 molar. Now in this case it was the same number. However, if you ever do one that doesn't have 1 liter, then you're going to have an incorrect number, and that'll throw you off. So do the same for bromine, it's the same thing. And then I know that initially, when I first start my reaction, iodine bromide, or my products, are going to be 0, correct? Because I haven't made any of them. So there we go. So 0 iodine bromide is going to be there initially. And then they also told me that at equilibrium, I know that the concentration of my iodine bromine is going to be, or iodine bromide, is going to be 0.84 molar. So now I've put in everything that they have to give me. And the rest is my knowledge of equilibrium. I know that equilibrium has to change at a constant rate. So they are going to start going back and forth at the same rate, which means that if I lose some amount of iodine, it's going to make some amount of iodine bromide. So I'm going to use X to represent this, and in my change box I know I'm going to lose my reactants, so they're negative X, and then I'm going to gain product. And since I have a 2 as my coefficient, I know I'm going to make twice as much product as I lost of iodine or of bromine. So iodine, bromine, there's my change. This is what happens when I'm trying to get to equilibrium. And then equilibrium is initial plus change. So whatever I initially started with minus the change, or plus, whatever the change is, that's going to give me what I have at equilibrium. So for iodine, I have 0.5 molar minus X goes in equilibrium. And then for bromine, I have 0.5 molar minus X. And then for my iodine bromide, sorry, I don't know why that's so hard to say, but I have 0 initial plus 2X equals 0.84. So that's the only one I have so far. So I'm going to solve that out for X, and I get X, or the change that's occurring in my chemical equilibrium, is 0.42. I'm going to change, every time I go back and forth, I'm going to change by 0.42 for for my x. Alright? So then, once I know my x, I can solve for my iodine, because my equilibrium for iodine is 0.5 minus x. And I know what x is, so I do 0.5 minus 0.42, and I get 0.08. That's my equilibrium concentration for iodine. That's how much iodine I have at equilibrium. And then bromine is the exact same thing, and so his concentration is also 0.08. So what this table means is that initially, if I start off with 0.5 molar and 0.5 molar of my bromine and my iodine, I am going to, the reaction is going to take place and is going to start making product. And I'm going to lose my reactants and I'm going to gain products until they're at equilibrium, until they have, their rates are the same. Then, at equilibrium, once I have reached equilibrium and both are good, I'll have 0.08 molar iodine, I'll have 0.08 molar bromine, and I'll have 0.84 molar iodine bromide. Okay, so that just means that those are the concentrations at equilibrium of each substance. So then, the actual question that I needed to answer is, what is the value of KEQ? So now that I have my concentrations at equilibrium, I can plug them into my equation, just like so. Solve it out. I get KEQ is equal to 110. And with sig figs, KEQ is equal to 100. Alright, so KEQ is equal to 100, and that is my equilibrium expression. Alright, so that is the ice table we went over in class. Now I'm going to do one that is different. Okay, so new question. Consider the following reaction. 2NO plus 2H2 goes to N2 plus 2H2O. Determine the value of the equilibrium constant for the following reaction. Initially, a mixture of this, and this was allowed to reach equilibrium. Initially, there was no N2. At equilibrium, the concentration of NO was found to be this. Alright, so here we go. First thing I do is I write my equilibrium expression, because that's, what they're asking for. So, oops, I forgot to push my brush. Sorry about that. Alright, so K is going to be equal to my nitrogen times my water. My water needs to be squared because of that coefficient. Then I need NO. And then I need, oops, got the square, my bad. Then H2. And he's got to be squared too. Alright, so check my work. But that should be the equilibrium expression. Products over reactants. Then, it says initially, and then it says equilibrium. So I'm guessing I'm going to have to make an ice table. Okay, so I created my ice table, and I filled in the information they gave me. Alright, so they told me that nitrogen monoxide was 0.6062 at equilibrium, and they told me my initial concentrations. Now, again, I'm going to use my thinking cap, and I'm going to say, okay, if I have this reaction, I know that nitrogen monoxide is going to change twice as much, and it's a reactant, so I'm going to lose. Oh, man, I guess I need to plug in my computer. Alright, so I'm going to lose this minus 2x, and then minus 2x, and then nitrogen I'm going to have to add, and then water, since we've already started off with some, I know I'm going to have to lose some water as well. So I have minus 2x plus x, there we go. Now I just need to figure out, well, what is x? So I know I plus c equals e. So 0.1 minus 2x has to equal 0.062. And if I solve for that, X is equal to a really cool number. Give me a second. X is equal to 0.019. Alright, so then I'm going to do 0.05 minus 2 times 0.019. We're going to fill in for X. That's going to be my hydrogen. And then I'm going to have X is equal to, X, and that's my nitrogen. So nitrogen is 0.019. And then H2O is going to be 0.1 minus 2x, or 2 times 0.019, and that's going to give me my water. Alright, so now that I have the concentrations for hydrogen, nitrogen, water, and NO, I can look up here, and I'm just going to plug these guys back in to my K equation. Alright, so I'm going to do, I know that nitrogen is 0.19, 0.019, and then I'm going to multiply that by water, which was 0.062, and I'm going to square that. And then nitrogen monoxide is 0.062, and I'm going to square that. It's a square. Times hydrogen, which is 0.012, and I'm going to square that. And once I put that all into my calculator, I get an answer of 8.18. So that means that the equilibrium constant for this reaction is 8.18. So now that we've looked at that, if you want, there are other practice problems online you can look at. Just Google equilibrium ice tables, and they usually just pop up, and there's different practice problems for you. So the big thing about ice tables, make sure that you write out the information that they give you. Remember to calculate your change and include the coefficients. And then after that, it's just a lot of math. And once you have all of your math done, you can find what they're asking you for. Alright, thanks for tuning in.